please feel free to ask me. Otherwise, if not, then we can move further. Alright, so let's start with TCP/IP model. So, have you heard of these two terms, TCP and IP? IP is Internet Protocol. We have quite extensively studied it from its nomenclature perspective. Yes.
TCP is transmission protocol.
Transmission control protocol. Yes. We may have touched this, a little bit of it, but overall, this is something that we widely use in our modern day technologies. Anyways, today's part of discussion with this is a little bit what we have already studied, which we have already covered. So this looks a little bit similar, not exact, but most of the terms over here you might have already learned them, studied them, reviewed them. At least you have an idea about them. There are some keywords which may be not familiar to you, but now we are going to understand them. Okay. So if you want to write them down, you could, but if you do compare this with an OSI reference model, it's almost identical. It's almost same. Hardly there are any changes. But what are the changes? The changes are in application layer, you could say. So over here in this slide or in this model, TCP/IP, which is our modern day communication and technology, how things are moving and how things are processing, this is also a reference model that we use for our communication. So for IP, this is what we generally understand for our modern day technologies. OSI reference model is used to understand holistically how things are happening and how things are working, but mostly this model is for IP-based communication, or you could say like TCP/IP based model. So there's not a difference much, as you could see by itself. Number one thing, physical layer. Physical layer, we already have covered it. So let me try to fix. Okay, yeah, that's fine. So layer number one is physical layer. Protocol on layer is almost nothing. As I have mentioned, there is no intelligence. There is only bits and bytes that runs on the data on the cable. Cables, connectors, hub, because they have no intelligence, no operating system. So it's not an intelligent layer. Okay. The protocol data unit over here is bits, which we have already covered. Some of the things which may not have been we have studied, and definitely you guys gonna ask me that what is a bit, frame, packet, datagram, segment, message. You have not heard of it. Yes, because we have not touched them yet. But the point over here for the discussion is that, let me give you a non-technical example and you will understand it. So, if I want to move, or if someone moves, or if I would say like a baby moves, there's a phase called crawling. So babies do crawl. Then there's a phase, babies start to walk. It is still movement, but it's not crawling. But then there is a phase, the kids or the toddlers, when they become toddlers, they would start to run, or sort of a brisk walk. So crawling, walking, brisk walk, running, what are all these? Different movements. Same is mentioned over here in this slide. So when the data is on layer 1, physical layer, we do not say this as a message or a segment. What we refer them to as bits. When the same data promotes itself and it goes on to data link layer, so on data link layer, what it becomes, what it's called? Frames. Same data. It's just like encapsulation, adding another layer information to another layer. So if the data was on layer 1, it's being told as bits. When it promotes itself to second layer, which is the data link layer itself, on data link layer there are additional protocols that are running, that are working. The purpose of data link layer, you already have covered it. We already have discussed this. So the same data, when it promotes with all those protocols, header informations, it becomes frames. When the same data promotes to the next layer, it becomes packets or datagram. So you may have heard of a term IP packet, IP datagram. So that is where these terms are coming. By the way, for data link layer to cover frames, we could do discussions like 2-3 hours just specifically on this, how it becomes, what are these things. But definitely it's beyond the scope of our discussion. And to be honest, you do not have to deep dive into it. We are not in a PhD class. I don't myself know much about it other than what I do on day-to-day basis. So you may have not to worry so much about all this. You just have to know it, and how much you know, we're just going to cover that piece. So the same thing, when it promotes itself, it goes on to layer 4, transport layer. In transport layer, it is being called as segment. So the segmentation, if you do remember what's the purpose of layer 4, it was for segmentation reasons. We are going to cover them again, so it's kind like of a refresher. In next 10 to 15 minutes, we are going to again cover all these layers what I have over. So I just explained you the protocol data unit, that on physical layer the data is called as bits. On the next layer, data link layer, it calls as frames. On third layer, it calls packets, IP packets or IP datagram. On fourth layer, it becomes segments. So it could either be a TCP segment or it could be a UDP segment. What is TCP? What is UDP? We are going to cover this in next 30 to 40 minutes. Any questions so far? So the protocol data unit is covered. This area is addressing. So these are addresses. Over here, this is addressing column, and in slide you would have these things as well. So one thing that I have not touched yet, you may have heard of it, that is MAC address. Is it a unique thing to you guys? Is it a unique keyword? Okay. Alright. This word is not just unique, it's itself is a unique term as well. So the next thing over here, TCP IP model. Again, these are some refresher slides just to get back to the momentum of our class. We are reviewing this. We have already covered, discussed them in detail in our first session. Today is the fourth session, but it's still a refresher for you. So what is a physical layer? Physical layer has no intelligence. It's bare bones. So this is with no intelligence. Why there is no intelligence? Because there is no operating system over here on this layer. Software, what makes intelligent? Not the bulky muscles make, the brain makes the smarter decisions. So this smartness comes from an operating system, and unfortunately on layer 1 we don't have that option with it. Or next thing is that it represents the physical devices that are connected or that interconnect computers. So cables, connectors, hubs, we have already seen them physically as well in our last session. This includes the specifications of the networking cables and connectors we just have discussed with. Data is sent as signals over these connections, like voltage. I told you that because these are physical cables, so the data that is going to be is in voltage. If you do remember, I said that the data is sent in zeros and ones. There is a signal, there would be no signal. zeros and ones, yes and no, on and off, true and false, in that format. So either there would be a signal or there would be no signal. Alright? Last statement we already have covered. Next layer. Next layer is the data link layer. The second layer of our model is known as data link layer. Some sources also say this as an access layer. Sometimes it's referred as network access layer as well. But for your own simplicity, you could say data link layer. So at this layer, the intelligence starts to come up. The intelligence starts to build up. Why? Because there are some protocols that are being used over here. There are some standards that are being used over here. There are some devices that operates purely on layer 2. So while the physical layer is all about cabling, connectors and sending signals, the data link layer is responsible for defining a common way of interpreting these skills so network devices can communicate. Lots of protocols exist at the data link layer, but the most common known as Ethernet. This is what we generally on day-to-day basis use. That is what last time I showed you Ethernet port as well. We did connected my computer, my laptop with the firewall via Ethernet cable. Okay, so it's not a new term for you guys. Wi-Fi is also a layer 2 technology, you would say. Okay? So although wireless technologies are becoming more and more popular, but we generally going to understand all this through the perspective or through the lens of Ethernet. Beyond specifying physical layer attributes, the Ethernet standards are also define a protocol responsible for getting data to nodes onto the same network. I showed you last time where there was a switch with us. We could connect multiple devices over there, and all those devices could communicate with each other via Ethernet. Okay? So this is not a new thing. If anyone wants coffee or donuts, they could go. Okay. Most important thing of our today's session. On every layer, we do have something to address, like we use addressing scheme. Similarly, when just to give a non-technical example, when I'm at home, I may not be called by my first name. It could be something else. On my job, most of the times, or when I do send an email or I do receive an email, I may get responded back on the basis of my last name. My friends would call me with a different name if they are close to me. So you see, like wherever I am, I'm being addressed in a different way. Same thing happens in our communications, in IP communication as well. On layer 2, the address that is being used is called MAC address. IP address is on layer 3, which we already have covered. On layer 2, on data link layer, when the communication is happening, it happens on the basis of MAC address. What is MAC address? Media access control. Media access control, MAC address. So, how we are going to understand MAC address? We're going to understand this by comparing with IP address. So before I deep dive into the slide behind me, number one thing for MAC address. MAC addresses are globally unique addresses. Globally unique addresses. Just as an example, my name is Kumar. But am I the only one Kumar in this whole world? No, probably not. Surely for not. Because I do know Kumail is outside there. So my name is not globally unique, but MAC addresses are globally unique. Okay. If they are globally unique, this is very interesting thing then. Yes, it is very interesting. Because whatever the MAC address my Ethernet port has on my laptop, no one else in the world has this MAC address. And that is a surprising thing. Interesting enough, if I have two interfaces, two network adapters on my computer, one network adapter is Ethernet, other one is Wi-Fi, they both are layer 2 standards, data link layer, both would have a different MAC address and they both will be globally unique. So even in my same machine, these two MAC addresses are different MAC addresses. And I'm going to show it to you. So whatever MAC address that you have on your laptop would be globally unique. That is how they do keep tracking on all of these things. Fun fact. You guys all have phones with you. If you go to the settings, if someone wants to do it right now, they could go and check. Their phone would also have a MAC address. That would not be an Ethernet based MAC address, but it would be a different, but for your Wi-Fi interface, for your phone, you would have a different MAC address. Yeah, it may be difficult to find it out, I do not exactly recall, but if you do, an iPhone, if you do go into settings, your phone, about, if you scroll down, top down menu, you may find it. Well, speaking of this,
Is there a Wi-Fi address the same as MAC address?
sorry?
So Wi-Fi address same as MAC address?
Let's see. Yes. So could you see like here in iPhone, the Wi-Fi address you could see is a different one than your Bluetooth address interface?
Yes.
Because Bluetooth is also kind like of a native technology. So you see, I have not come as like this is a unique thing. No, this is a unique thing in one way that yes, it do exist. Again, the vendors itself are managing these things for you. So you do not have to worry about this. But this is going to be globally unique. If you do compare with each other, you would find this as different everywhere. Okay? So MAC addresses, you could understand that how they have been operating. Like this is a whole new world to you right now. So last 5 seconds before your world was different, now it's different just because of understanding MAC addresses. So that is the importance of MAC address. Why MAC addresses are important? MAC addresses are important because the communication on layer 2 happens on the basis of these addresses. The nomenclature of these addresses, if you do have seen this on your phone, I'm not exactly sure, but yeah, let's try to see this. It was under settings. I believe it's in general and about.
Yes.
General, about,
Scroll down.
and when you scroll down, you would find Wi-Fi address and Bluetooth address. Okay? So let's just focus on Wi-Fi address. If you have seen this on your phone, it is going to be 12 characters. It is going to be 12 characters, and all those characters are being divided into 6 groups with a colon. Okay? So, the nomenclature is that a MAC address is 12 hexadecimal character system. 12, so 12 hexadecimal characters. What is hexadecimal? Hex means 6, 6, Decimal, we already covered it, 0 to 9, 10. So 6 plus 10, 16. This is the nomenclature of 16 characters. So the range would going to be from 0 to 15. I know this is little
Can you say it again?
non-spicy thing, so I'll try to make it a little spicy. So a MAC address consists of 12 hexadecimal characters. 0 to 9 are decimal, like 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So 10 characters are there. The next 6 characters, because it's a hexadecimal, decimal is already there. Hex means 6. So the next 6 characters are A, B, C, D, E, and F. So 0 to 9 becomes 10. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. This becomes 10. Now A, B, C, D, E, F. 6. So its range is from 0 to F. That is why you would see A, B, C, D, E, F. But there would be no G in a MAC address. That's for sure. So how it's being written? It's being divided into 2 groups. So there would be total 6 groups, and 6 groups each would have like 2 characters in it, and that is how it's being written. Any question? I'm on purpose slowing it down at a very basic level, because by the end of this session, I just want you to say 2 to 3 words or 2 to 3 statements on MAC address. This would be a term that you most likely see. And when you do troubleshooting routing and switching issues, this term is very important. So what is a MAC address? MAC address is a unique identifier assigned to a network interface. Network interface? Exactly. NIC controller. So an Ethernet is a network interface. A Wi-Fi is a network interface. Even a Bluetooth is a network interface. You just have seen it. So a MAC address is a 48-bit identifier. That address assigned to every network interface, such as Ethernet or Wi-Fi adapters. One thing is very interesting. We have discussed these are 12 characters. Fun fact, the first 6 characters are manufacturer controlled. These are unique identifiers. Every manufacturer would have the series of them. So for example, if again like any MAC address so for example, I do have an iPhone in hand of me. So for it, it's 98:A5:F9. So if someone who is expert in MAC addresses, if it just sees these 6 characters, he's going to pinpoint that, oh, this is a Mac device or an Apple device.
I have Apple, but it's
It would be different because these are like billions of devices out there.
okay.
It may be something else
Then
that you.
60 D0 D0 39 11 B366.
Every device has
That-
a different MAC address.
Yes, every device would gonna have a different MAC address, but the first 6 characters, like in this case 98A5, whatever is your.
Their Bluetooth and Wi-Fi, their first 6 are similar. So I believe it varies on the device.
Yes, it is going to vary on this device. And another thing to imagine is that every vendor would not just have only one pool of it. They would have different pools. They would have thousands and thousands of pools. But most likely your Wi-Fi address and Bluetooth address would be in the same range.
Yeah, they're both same.
Almost.
So in
First
your
six
case
are
it's
same.
98.
Last character is changed.
Yes. Yes. Yeah. Cause these first 6 characters are manufacturer's identity. The last 6 could be any random number. Even there are some websites, if you go over there, you just put your MAC address and search that, okay, which vendors this MAC address is. So even those websites gonna tell you, okay, this is for this manufacturer, this is for that manufacturer. Because you could say like, these first 6 characters are being allotted them by the industry standards, so that at least they would know that, okay, where this device is or who's the manufacturer of this. That is how it's globally unique. If everyone starts to generate their MAC addresses, then it would not have been globally unique. Okay? So that is how they are controlling it. If I would make my own devices, I could have randomly generated a MAC address, but it's same as you guys, and there could be a conflict. But if I would have given 6 character block that, hey, Kumar, this is your block, these are going to be fixed. And once this pool is exhausted, you could have another pool. Once that exhausted, then we'll give you another pool. If then it exhausts, yes, you could have another pool. But the other 6 characters you could generate. And there are like billions and billions of combinations that you could make out of the MAC address. So that's why we are not afraid or worried about the shortage of these MAC addresses.
How can we generate like millions or billions with only 16 characters?
There's a science behind it. If you do calculate this by putting 2 raised to power 48, so 2 raised to power 48 means that if it was 2 raised to power 7, if you do remember that. So what was the number maximum? 255. If you make it 2 raised to power 8, it would become 512. The next number is 1024, then 2048, then 4096, 8192. That is how they are making all those things. 2 raised to power 15 means 65,535 from 0 to that number. If we'll just add one number to it, it becomes huge. So that is how like they are like billions of addresses.
In IP address, there is a 255 is the last number, right?
Yes.
And there is a MAC as well too, and this specific number?
Yes, 0 to 9,
Okay.
and then A, B, C, D, E,
F.
F. So the combinations are going to be around these numbers only. There would be a no G, H, I, J, K, L, M, and so on. So if you do see a MAC address, or if there's a question comes in an interview, if it has any number outside of A, B, C, D, E, F, G, E, F, and beyond any numbers after F, then it's not a valid MAC address. Any question? Okay. So network communication is why MAC addresses is used. So network communication, MAC addresses are used at the data link layer of the OSI model to facilitate communication between devices within the same local network segment. This is very important statement, and I kept it as is. Assume there is a switch, which you already have seen by now, and there are 10 computers, 10 devices, IP camera, printer, laptop, a server, any other thing that has an Ethernet port, and all of them are connected with the Ethernet, with that switch. All that communication would be happening on the basis of MAC address. Yes, we do need IP, but we also do need MAC address. And in order to send traffic to each other, because they are on the same LAN segment, local area network segment, they are going to use MAC addresses. Now I'm going to give you a very fun situation also. Assume you're sitting here and there is a user or a device that may be somewhere else in the world. It could be in cloud, it could be a physical device. If you do want to send your data to that device, or if you want to reach out to that service, within the cloud or within the physical premises, you just only need MAC address for communication within your local area network, within the LAN. These MAC addresses do not travel outside of your network. An IP address could travel outside of your network, and it is likely, as you have seen in the cases, that when you do type what is my IP address, you would search it and you would find it. But MAC addresses are globally unique and they are only used in your local area communication. So most likely, if you're sending data to me and we are not the part of the same network, I would never see your MAC address. There isn't going to be a possibility that I'll extract your MAC address. So it is something that is generated on the network, that is the part of the local network, that stays on local network. You may have heard of a term routing protocol, RIP, OSP, FEIG, IP, I know you have heard of it. Those are used for routing, like IP address, IP information going one place to another place. We do know where does that IP exist, where does those routes are coming from. For that, we are using routing protocols. In this case, MAC addresses, there is no routing. There is none required. So in other words, you could say like your MAC address is safe. It's your intellectual property. It's gonna stay in local area. I know it's not spicy. I'm trying to make it. So you just hasn't very spicy. Okay. Another very important thing. MAC addresses are also called physical addresses, burnt addresses as well. Why? This becomes the DNA of the interface. You cannot change them. You cannot remove them. But there are ways that you could do, but 99.9% it's not going to change. It's not going to be used somewhere else. So these are physical addresses, just like as DNA. You cannot change you can change your name, you can change your number. Your number is also an identification. Your name is also an identification. But your DNA is something that you cannot change. Same as with MAC addresses. MAC addresses cannot be changed. So whatever MAC address has been allotted to my iPhone or my Bluetooth interface or onto my device, I am gonna stay with it. And there is nothing like it, there's no golden number or something like that. It is what it is. It's just used for communication behind the scenes. It's not like, no, my date of birth starts at this, I want this MAC address to be the part of my device. No, most likely you won't fulfill that request. Okay? Any question? Alright, so when data is sent over a network, it is encapsulated in a frame. Again, the keyword frame because we are on layer 2. It's not IP datagram, it's not bits because we are studying layer 2. So, that is why you have said, when data is sent over a network, it is encapsulated in a frame. That includes the MAC addresses of the sender and recipient. So if I will be sending data on layer 2, I would be giving my MAC address and you will be sharing your MAC address, and that is how on the basis of that communication happens. Okay. Next two statements are very important. You may not understand them now, and that's fine. So MAC addresses are being used to resolve our address resolution protocol. If this protocol does not exist on your network, most likely we won't be able to do communication. Our address resolution protocol. I'm not going to explain this in detail because I'm not explaining ARP, I'm just here to dictate MAC address. But just giving you an example of ARP and the procedure, how it works. This is something that I would expect from every engineer, even if it's junior, beginner level, or an industry level expert. I would at least ask him these things if I'll be interviewing them. So what is ARP? I'm just going to explain the whole process in a very simple way. If I come here in this room and if I say that, who's Hasnan? So what I'm doing?
Asking a question.
asking a question, I'm broadcasting a message on the network. And in response, someone would say that, hey, I am Hasnain. He's sending me a unicast message, he is letting me know this. So, this is the purpose of our address resolution protocol. On network, when we want to send data on layer 2, we ask their MAC addresses. We say that, hey, this is me, this is my IP address, for example 10.1.1.1. This is my MAC address. Let's assume I'm a device. I'm say that, hey, I am 10.1.1.1. My MAC address is A. You would most likely be 10.1.1.2, but what's your MAC address? So in response, a resolution would come and say that, okay, I'm 10.1.1.2 and you are, and I am B. So that is how we exchange MAC addresses with each other. So once we know the MAC addresses, then we unicast the communication. So if I come in this room and I say that who's Hasnain, I'm trying to do an ARP resolution, address resolution. Someone would respond to me. Once I know that, yeah, he is him, then I would go in person and talk to him. So the first communication is broadcast, and every other communication onwards, once I know its MAC address, would going to be unicast. That is why it's an important concept. So do a little homework for you guys. Go and study ARP resolutions. There are very beautiful articles out there. Even you could have some animation related videos on YouTube as well. That how does ARP works. Next thing, I already covered a little bit that why MAC addresses are being used. MAC addresses are essential for network switches to forward data frames to the correct destination within a local network segment. Routers also use MAC addresses for forwarding packets between different network segments. I think we have discussed a lot about MAC addresses. Any question? Just review the slide. Any question? So what is a MAC address?
Unique identifier, globally unique address.
Awesome. Globally unique identifier. The presence of a MAC address is required on layer 2 so that we could have communication. Yes.
On a local network, if it changes, but if it's like if the connection is distant, then it transfers to the IP and only the IP address
Yes.
is transferred out.
And it's on local segment. So for example, assume again, like I could not draw this right now, but let's just visualize. I have a computer, this one. This is connected via Ethernet cable to a switch. And there is a device which is behind the switch. So I need MAC address on this segment to communicate. For example, this is the computer, this is a switch, this is a router, and something else is on the cloud. So the MAC address would only stay in between this area. It would not go beyond to router. Does that answer the question? So the likelihood or livelihood of a MAC address is within that local area. And that is why there is no shortage of these addresses. If these would be globally routable addresses, if we do need all the MAC addresses information, these billions of addresses could have not been saved. It would almost impossible to communicate on the basis of local area or on wide area. Any question? Next layer, network layer. Now you guys know more than me about network layer. We have covered all these things. The third layer, the network layer, is also sometimes called the internet layer because we have seen that how internet works now, a little bit piece of it. It is this layer that allows different networks to communicate with each other through devices known as router. We already have covered that router is a device that works on layer 2, layer 3. And an address that is being used on this layer is called IP address. A collection of networks connected through routers is an inter-network, the most famous of these being the internet. Okay. While the data link layer is responsible for getting data across a single link, the network layer is responsible for getting data delivered across a collection of networks. Okay, before I go further, a fun fact question again for you guys. So, I do have an interface. For example, this is my laptop. It has an Ethernet port. Can I configure an IP address on this interface? Yes, I can. Can I configure a MAC address on this?
No.
No, I cannot configure a MAC address. But can they both coexist at the same time?
Yes.
For the ones who are saying yes, why? And for those who are saying no or not answering, why? I do need an explanation.
So, yes, इसलिए क्योंकि it is like there for it's a unique global unique thing and it has to be there and for IP address if you are networking you would need an IP address. I don't know.
Yes, yes, correct. So the short and simple answer is yes, they both can coexist. Why? Just imagine your friends would be calling you with some other name, but your passport and your driving license would have your actual name, but your relatives might call something else. At home you are being called something else. What they are using for communication? The address they know, or that's easier for them to communicate with you. Same thing is over here. So with these addresses, layer 2, whatever is happening on layer 2, it's being called at layer 2 as that address. An IP address is configured on layer 3. On layer 3, its presence is being detected or being known by this address. Just give me.